Alright folks, back for another one. Now we're going to do chapter 4 review. And the title of chapter 4 is a first analysis of feedback. And so there are really, chapter 3 kind of did a lot in terms of block diagram and reduction and things like that. But now we're looking at something called steady state error. And so what they create is a table where they write the type of the system, 0, 1, and 2, and then they write the input type, step, ramp, parabola. And they say that if you have a type 0 system and it gets hit with a step, you have constant steady state error. If you give it a ramp, you have infinite, and a parabola infinite. If you hit a system that's a type 1 system with a step, or a type 2 system, you actually have no steady state error, and then you actually kind of just go down like this, infinite, and this is, like this. And so this tells you steady state error as a function of type, okay? And so to do this example, or to sort of highlight this, let's just do two simple examples, okay? So I'm going to take a system that has k, so I have proportional control, and I'm going to have 2 over s plus 3. This is my transfer function, plus minus. And I'm going to close the loop on this and hit it with a step and use the final value theorem to compute the final value. So I'm going to close the loop on this real quick, right? So you do cascade, so you're going to get 2k over s plus 3 in the numerator, and then you're going to get 1 plus 2k over s plus 3, right? Cg over 1 plus Cgh, h in this case is 1, right? H is equal to 1. So you get Cg in the numerator, this is C, this is G, and then you get 1 plus Cgh in the denominator. In order to get rid of this improper fraction, you multiply by s plus 3 over s plus 3, and you get 2k over s plus 3 plus 2k. If you hit this with a step, the steady state value, right, if you plug in s equals 0, is 2k over 3 plus 2k, okay? Steady state error is the input R, is the input R minus your steady state value. Well, your input R, if it's a step, R is equal to 1. So R is 1, that's a step. Okay, it's a constant force, it's a constant reference command, it's a step. So if I do E steady state equals 1 minus 2k over 3 plus 2k, if I do 3 plus 2k over 3 plus 2k and subtract off 2k over 3 plus 2k, I get 3 over 3 plus 2k, okay? Now, as k goes to infinity, my steady state error drops to 0, but it's basically a constant as long as k is a constant. But it's not 0. You'll never get there, okay? Now, let's do this problem again, except let's increase the type. So what's the type? The type is the number of integrators, okay? So I'm going to increase the type of the system by, I can't change the plant. The plant is the car, it's the plane, it's the train, it's whatever system you're given. You can't change it unless you redesign the vehicle. But the control system is the software, so you can edit the software, okay? So we're going to do this again now. I'm going to attempt to leave this here, except I'm going to do k over s, right? So now I've added an integrator, so I've increased the type of the system. Okay, and then I'm going to do the same thing. I'm going to do Cg over Cg plus 1 plus Cgh, and so I'm going to get 2k over s plus 3, 1 plus 2k s plus 3, and I'm going to multiply by s plus 3 over s plus 3. That's going to cancel. I'm going to get 2k in the numerator, and this is what's interesting that happens in the denominator, and this is why integrators are so nice, is that I'm actually going to get s squared plus 3s in the denominator, and then this is going to cancel here and give me 2k. Okay? And if you look here, if I hit the system with a step, what's the final value? Well, the final value is just 2k over 2k, which is 1, which means the steady state error is r minus x steady state, which is 1 minus 1, which is 0. So see here, type 0 system, right? This is a type 0 system, there are no integrators, a constant steady state error. Over here, I increase the type of the system to 1, so when I close the loop and hit the system with a step, my steady state error drops to 0. All of this math here that I just did is unnecessary if you just use the table. If you're given this transfer function and I say, is the steady state error 0? You would say no, because the type of system is 0. If I gave you this control block diagram, and I said, what is the steady state error? You don't need to show all this work. The answer is 0, because the type of the system is 1.